How to calculate pi using rectangular quadrature? From mathematics, we know that if you calculate the definite integral from 0 to 1 of 4 over 1 plus x squared, we will get the value pi. Here is the portion that we would have to calculate the area for. If we divide the shape into 4 parts, like this, so we take the value of the function in the middle of this portion, that is, at 0.125. This rectangle gives us an approximation of the area under the first part of this curve. The height of the rectangle is calculated by replacing x with 0.125 in the formula. The result is 3.9384. The area of a rectangle is width times height. This gives us an area of 0.9846. Now we go on to the next section. We repeat the process by taking the middle of the second section, forming the rectangle of the height in the middle. The height is 3.5068. The area is 0.8767. Now we proceed to the third section. And we do the same thing. And we find the approximation of the area here is 0.7191. And now for the last section. Which gives us 0.5664. Now we've got all 4 sections. We sum them up and get our approximation for pi. Obviously, the result is not that accurate with only 4 divisions. The more divisions you make, the more accurate it becomes. The following animation shows what happens if we run the MPI pi calculation program using 4 processes. All 4 processes start running at the same time. Each process has its own set of variables from the program. The number of processes in our example is 4 and is the same for every process. Initially, the only difference between the processes is the rank. Interaction with the user, or input-output, is usually only done on the process with rank 0. In a real calculation, it would have many more than 100 partitions, but in this example, to keep the animation manageable, we shall choose 100 partitions. Process 0 then broadcasts the number of partitions to all the other processes. Every process then calls the pi function with the num partitions. Each process calculates the same step size. This is because such small calculations usually take less time than having process 0 calculated and then send it to every other process. Each process starts with a different I, which is based on the process rank. Because each process has a different I, it then calculates a different X, and so subsequently a different total. Each process then increases by the number of processes. This ensures that each process does a different slice of the curve. Now I is still less than num partitions, so we continue the loop. Each process then proceeds with a new I, which generates a new X. And hence adds to a new total. And now for the next round. Now I is still less than num partitions, so we continue the loop. Finally, I is no longer less than num partitions. So we calculate the subtotal for this rank and return it. The numbers returned from the function pi must be entered in local result. The numbers are: for 0 is 0.792876. For 1 is 0.787926. 2 is 0.782924. And for 3, it's 0.777874. Then finally, the MPI_reduce collects those 4 local results and adds them together, and puts the total in result in process 0 equals 3.141601. Process 0 prints pi is approximately 3.141609869231245000 using 100 partitions.